All right, guys, here we go. We're going to start this case out, try to give you our default settings and just walk through this first, like very basic lingual bar. First things, we always default on our cases to 4 degrees blockout. So if you don't have this setting open when you're working, you can set that parameter in your default settings, which we can look at later. But anyways, these are all surveyed and designed. The biggest thing is that we're balancing this path of insertion, which you probably are already familiar with. So just looking at this case, I would add a little additional block out here. Maybe a little here. Okay, looks good. Next. So we have a lot of the DME library here, and everything will end with the part dash BDL. So 95% of the cases we use this pattern here, this very first one, the mesh dash BDL. It's just a simple circle. Our second default here is 0.60. That for us means regular sheet relief or regular spacing. We do sometimes go up, and when we have an increased thickness that we want, we actually write H for heavy on the model, and we go to 0.8. And if there's a T, that means thin, and thin is 0.4. So that's the kind of breakdown. 0.4 is thin, 0.6 is regular, which is 95% of cases. H is for heavy, and that's 0.8. So when we do these cases, all of our saddles, we basically do like a mesh, kind of get this hat, so they're half holes. We rotate this so that when we come back later and fill this leading edge, it's real clean. So I bring this sheet relief back, or resin gap as 3Shape likes to call it. We go next. Again, I'm going to go, this is your standard lingual bar here. My mouse is really sensitive. Like, I need to adjust this because it's just coming in and out pretty quickly. So we actually are trying to have a little bit, I'll say a step right here where it's like the mesh ends and then the lingual bar has a little, I'll say 90-degree step down. And we're looking at the drawing on our bars at the top, I'll say the very top edge of the drawing, and placing the top edge of the bar. You will run into some cases where you don't have quite enough room, and obviously then you could scooch this down vertically a little bit if you have to. Otherwise, we'd rather keep that bar the same width if we don't have enough room, floor of the model. On these, you always want, for us, you always want to turn these up because this adds a lot of strength. Like turn this up into this upright because this bar has a lot of nice strength. Like that. And I'll actually bring this in a little more and click this down a couple clicks. Hit preview. Okay, that's connected good. Now we're going to go to our, even though it's not, we know it's not a rest, I'm going to use this tool. It's the same thickness settings, 0.50 and 0.40 as our major connector. And again, note our stippling protection, even though this won't have any stipple, that's our default, the 0.5. So anyways, I'm gonna go, I'd personally just use this tool because I like that the pointer is, this is much smaller, the spline. I feel like it's easier to work with. I know people do this sometimes differently with, they'll just break out like just the individual rests. But this is what we've found gives us the nicest transitions for the frames. So I'm just sharing that with you. And I keep this within the green when I come back. So the most important part here really is just the leading edge on the top edge of the bar here. So again, I'm trying to really show how that meets up to the bar. And when you do finger rests, for us, like this finger rest here, you know, you don't want to be like this. We want this to be, think of like a tree. Like we want that, the base of that tree to be strong. So that's why we kind of flare that out at the bottom a little bit. Usually our drawings are pretty accurate, so they'll give you a good indicator. I like to think because of the team we have drawing, you know, they're literally just drawing partials all day, that they really know what they're looking for and what's a good design. That makes CAD so much easier because you can just, you know, go with the design. They've already been by hand surveyed and drawn on. So again, if you want, this transition will turn out really nice if you kind of just follow this leading edge of the bar like that. Come up. As you probably know, these double, I'll say double embrasure clasps are the most difficult, or they break the most easily. So I'm keeping enough width right here and enough width, especially right here. And notice how I kind of wrap this corner. Like I could be here, but I don't want to be because I'm going to end up with like a really hard, like a V shape right here when I place this clasp, and I want to avoid that. So I'm bringing this around this corner intentionally. I'm trying to provide as much info as I can because I just know it's very frustrating when you design a case on the computer and then people have their opinions after the fact. Everybody has an opinion. I see it. It just seems on RPDs, and you can spend, as you know, a lot of time reworking these on 3Shape, and that's what we really want to avoid for you guys as a team here, to try to streamline this and give you the best information we can provide. Okay, so just a C class for acres. You'll actually notice the pencil mark here. That's the by hand survey mark, and you'll also see what we call a scribe. We actually put a little scratch or a little score in the model. Right there you can see it. We put that little scratch just to tell our team, because we have both people hand waxing and CAD designing, where to place that clasp. For us, this X indicates that this clasp should be right on the tissue. Like we want that right down to the tissue line. There's not a lot of retention on this case, so that's what we're doing. Okay, now obviously I don't want this wrapping up over the top of the occlusion of the tooth, so I'm going to try to bring this down to get that below the occlusion there. There. Okay, so then we have the fill piece right here that we created. So this little half hole, we want to get rid of that. And then, like we discussed earlier, when we were setting up our mesh, this fill piece is going to be our bottom, I'll say leading edge on this saddle. I think I'm actually going to fill this hole right here as well. I definitely want to look at my thickness here to here and make sure this is not a weak area for breakage. I'm going to fill this as well for strength. Okay. So at this first sculpt step, the only thing I'm doing is looking at where the finishing lines will go. I'm not going to sculpt anything else. I know this finishing line is going to go right here, like so. So I'm just trying to lay this to get this flat because I know this finishing line will not lay flat and look nice if we don't have that prepped. This is the only part we use. It's super simple. It's just the wide finishing line. Tuck it a little bit under that first clasp, like that. So when I do my sculpting here, I'm a very low amount of, what do you call it, wax. Sorry about the phone in the background here. Got a phone call. So just a little bit of blending right there. A little more kind of right here in this, I'll say low spot. And when we're looking at this, we're using our thickness map at 1 mil. So we're bringing these rests just below 1 mil. So you just have just a little bit of barely seen red. And then I'm going to kind of define, I'll say I'm going to increase my intensity here. I'm going to try to define, there we go, the edge of that. All right. And the very last thing, our default here is 3 millimeters on the tissue stop. That's the one thing we never draw on our drawings, but on a free-end saddle like this, we always want a tissue stop right there. We're not going to need to do any crossbars or any sprue connectors. And with this being lower, there's no stipple. And our default, we always want to do this 0.050 for our line spacer. That's for our spacing when we're manufacturing. And next. And that's it. Just make sure that this tissue stop looks fully connected. Sometimes we have issues with that.